This is a rod. And let's go for the net force acting on the system. This is A. He has given this is B, and the wedge as C. Anybody? Net force it should be zero, no? So yeah, what are the forces now? Tension, normal contact N1 on the wedge, here N1 by 2 mg by the ground. Here, in what direction? If you release it, the wedge will try to shift towards left. So when it is moving, what is the direction of normal contacts? We have to show it. How the normal contact between the block B and the wedge. The rod will try to push it, no? The rod will exert force on the block towards left. In turn, the block will exert force on the rod towards right. Is that okay? That normal contact? Because see, like along the block will slide along the rod, and the wedge will be moving towards left. When it is moving towards left, the rod will push the block. So show that normal contact here in this direction. By the rod on the block. By the block, by the rod on the, by the block on the rod should be towards right. Anyway, I think it's like a on the, anyway, that will become, so like even, sir, I'm not sure about this. It should be equal and opposite here, no? N1 sin theta, here tension, here one tension. You can see like, okay, no, I'll show that particular force here. So this is like force acting on the rod, and on the rod, I'll show it here. It'll be easy for you. Everything will mess up there. Get into the problem, no? Net force along x-axis 0, no? So directly take help of formula and conclude the things. It'll be much easier. I'll go for the formula. Net force on system along x-axis 0. Okay, this, so center of mass will not shift along x-axis. Then mass of the block B, 3m minus xbx. Depth of wedge also, it will have displacement minus xc. Wedge, how much block? Oh, no, the block B is released from a height 27 centimeter above the floor. Find the displacement of the wedge when the block B touches the floor. When B touches the floor, then what is the displacement of wedge is asking. How much this let it move with respect to wedge, it will move, no? What is SAC, displacement of the block with respect to wedge along the incline. With respect to ground, how much it should be? SAX, so here I don't know that. I'll keep it here. Okay, let's come for the relative. So displacement of the block with respect to wedge along x-axis should be equal to SAC cos theta should be equal to displacement of block minus displacement of the wedge. Why negative sign? I know the wedge will shift towards left. So here you make things clear. So cos theta value is, we know cos theta 2 by 3. So let directly substitute this. 2 by 3 xax plus xc. Keep this equation in hand, or xax will write it is equal to 2 SAC by 3 minus xc. Here in this problem, we have string also. If it's simple trolley block something, okay, no need to make that one. But here the wedge is there. The string change in length of the string will come. So there I have to take that one. So don't make it generalized here. We can't generalize in physics. It all depends on problem. Most of the numericals, you need not to thus make a guess of sign. But here this numerical, I should assume something. Then I should proceed the problem. If I get negative, what I assumed is opposite. Okay, there's a one equation, keep it here now. So let me substitute all this, xax, here that one, we have here. So there's the equation 1, there's the equation 2. Put 2 in 1, minus 3m xbx minus 2m xc two by 3 SAC minus xc equal to 0. That's all, no? Let's solve. Take eliminate m. So we'll get relation between SAC, xbx, and xcs, that one. So I'll end up with equation minus 3bx 3xbx minus 3xc plus 2 by 3 SAC equal to 0. Keep this equation number 3. Let's come for some constraint equation. How much the block B will move along y-axis, that much what happen, the block M will move along the incline. Change in length of string. So I'm taking help of string now. Length of string remains constant. So therefore, how much block B moves along y-axis, that much what happen, the block A will move on the wedge along the incline, with respect to wedge along the incline. So XSAC shall I write equal to XBY? Due to string. So therefore, SAC should be equal to XBY. Do we know XBY? Yes. So from that, I'll get the difference. So what is XBY? XBY should be equal to how much? 27 centimeter. I think I'll directly come to this one. So this is one very important. He has given length of the string remains constant. So from the constant equation, the increase in length of this string should be equal to decrease in length of this string. Okay, fine. Constant equation. Then, so what is XBY? Do we know XBY? Yes, we know XBY. How much it is equal to? 27. So I know SAC. That I'll substitute here. Now come for any relation between XBX and XC. Displacement of block B along x-axis and displacement of wedge along x-axis. I think they are connected, no? You see, horizontal displacement of the block B and the wedge must be equal. One more. Horizontal displacement of block B and the wedge C must be equal. So therefore, what you can write here, xc should be equal to sbx. So there's equation 4, 5. Solving all this, we'll get the required answer. Anybody value? Put 4 and 5.
3 centimeters.
Yes, sir.
So it should be towards left.
Yes, sir.
Okay, no, so some constraint equations like this, anything they can include here. No? So just first go for net force acting on system 0, non-zero along axis, then proceed here. And where all strings are there, what you should do, whenever you get a string where blocks are connected to the string, then length of the string remains constant. So that also you're going to take help of here. The major part of the idea of the problem. Without this, I think we can't manage, you see, constraint equation. And this is due to rod.
So can you solve it, sir, further
Huh?
on substituting and all?
What ma? Like, I'm not getting, somebody is asking.
Nothing, sir.
Okay, no, the last one, I think time not there.